Now the chemistry in everyday life. So after studying this unit, you will be able to highlight the importance of the chemistry in the daily life, explain the term chemotherapy, describe the basis of the classification of the drugs, explain the drug target interaction of the enzymes and the receptors, explain how various types of the drugs functions in the body, know about the artificial sweetening agents and the food preservatives, discuss the chemistry of the cleansing agent. So from the living perception to the abstraction thought and from this to practice. By now you have learned that basic principles of the chemistry and also realized that it influences the every sphere of the human life. The principles of the chemistry have been used for the benefit of the mankind. The think of the cleanliness, the materials like soaps, detergents, household bleach, toothpaste, etc. will come to your mind. Look towards the beautiful clothes. Immediately chemicals of the synthetic fibers used for making the cloth and the chemical giving colors to them will come to your mind. Food materials, again a number of the chemicals about which you will learn in the previous unit will appear in your mind. Of course, sickness and the disease reminders of the medicine, again chemicals, explosive fuels, rockets, propellants, buildings and the electronic materials, etc. are all chemicals. Chemistry has influenced our life so much that we do not even realize that we come across chemicals at every moment, that we ourselves are beautiful chemical creations and all our activities are controlled by the chemicals. In this unit, we will learn the application of the chemistry in the three important and interesting areas, namely the medicines, food materials and the cleaning agent. तो आता है ड्रग्स एंड द एप्लीकेशंस. तो ड्रग्स आर द केमिकल्स ऑफ द लो molecular mass 100 से 500 U. These interact with the macromolecular target and produce a biological response. When the biological response is therapeutic and useful, these chemicals are called the medicines and are used in the diagnosis, prevention, and the treatment of the disease. Most of the drugs used as the medicine are potential poisons if taken in the dosage higher than those recommended. Use of the chemicals for the therapeutic effect is called the chemotherapy. Classification of the drugs. So drugs can be classified mainly on the criteria outlined as the follow. पहला on the basis of the pharmacological effect. So this classification is based on the pharmacological effect of the drugs. It is useful for doctors because it provides them the whole range of the drugs available for the treatment of the particular type of the problem. For example, analgesics have pain-killing effect and the antiseptics kill or arrest the growth of the microorganism. दूसरा on the basis of the drug action. It is based on the actions of a drug on a particular biochemical process. For example, all antihistamine inhibit the action of the compound histamine which causes inflammation in the body. There are various ways in which the action of the histamine can be blocked. You will learn about this in the section 13.6.3.2. फिर आता on the basis of the chemical structure. तो it is based on the chemical structure of the drug. Drug classification is the drug classified in this base share common structure feature and often have similar pharmacological activity. For example, sulfonamides have common structural feature given below. There is a structural feature of the sulfonamides. तो सल्फोनामाइड का स्ट्रक्चर फीचर ये दिया हुआ है. इसके बाद फिर आता है ऑन द बेसिस ऑफ द मॉलिकुलर टारगेट्स. ड्रग्स यूजुअली इंटरेक्ट विद द बायोमोलिक्यूल्स सच एज द कार्बोहाइड्रेट्स, लिपिड्स, प्रोटीन्स एंड न्यूक्लिक एसिड्स. दीज आर कॉल्ड द टारगेट molecules for the drug targets. Drug possessing some common structural features may have the same mechanism of the action on the targets. The classification based on the molecular targets is the most useful classification for the medicinal chemist. फिर आता है ड्रग टारगेट इंटरेक्शन. तो macromolecules of the biological origin perform various function in the body. For example, proteins which perform the role of the biological catalyst in the body are called enzymes. Those which are crucial to the communication system in the body are called receptor. Carrier proteins carry a polar molecule across the cell membrane. Nucleic acid have coded genetic information for the cell. Lipids and the carbohydrates are structural part of the cell membrane. These all explain the drug target interaction with the examples of the enzymes and the receptors. इसके बाद आता है enzyme and the drug receptors. Catalytic action of the enzyme. For understanding the interaction between a drug and an enzyme, it is important to know how do enzymes catalyze the reaction. In the catalytic activity, enzymes performs two major functions. पहला, the first function of an enzyme is to hold the substrate for a chemical reaction. Active sites of the enzyme hold the substrate molecule in a suitable position so that it can be attacked by the reagent effectively. Substrate bind to the active site of the enzyme through a variety of the interactions such as the ionic bonding, hydrogen bonding, van der Waals interaction और dipole-dipole interaction. तो ये enzyme हो गया, substrate हो गया और the enzyme holding substrate हो गया और इसका active site हो गया. तो active site of an enzyme substrate held in the active site of the enzyme दिए हुए. इसके बाद फिर आता है the second function of an enzyme is to provide the functional group that will attack the substrate and carry out the chemical reaction. So drug-enzyme interaction. Drug inhibits any one of the above mentioned activity of the enzyme. This can block the binding site of the enzyme and prevent the binding of the substrate, or can inhibit the catalytic activity of the enzyme. Such drugs are called the enzyme inhibitors. Drug inhibits the attachment of the substrate on the active site of the enzymes in two different ways. पहला कि ड्रग्स compete with the natural substrate for their attachment on the active site of the enzyme. Such drugs are called the competitive inhibitors. तो जैसे ड्रग है और द ड्रग एंड द सबस्ट्रेट कंपीटिंग फॉर द एक्टिव साइट के लिए है, तो ये एक्टिव साइट ये एंजाइम हो गया, ये सबस्ट्रेट हो गया, ये ड्रग एंड द सबस्ट्रेट कंपीटिंग फॉर द एक्टिव साइट ऑफ द एंजाइम. फिर इनहिबिटर्स ऑक्युपाइंग द एलोस्टेरिक साइट. फिर नॉन कंपीटिटिव इनहिबिटर्स changes its active site of the enzyme after binding at a allosteric site. इसके बाद आता है कि some drugs do not bind to the enzyme's active site. These bind to a different site of the enzyme which is called the allosteric site. This binding of the inhibitor at the allosteric site changes the shape of the active site in such a way that the substrate cannot recognize it. If a drug blocks the active site of the enzyme, if the bond formed between an enzyme and the inhibitor is a strong covalent bond and cannot be broken easily, then the enzyme is blocked permanently. The body then degrades the enzyme inhibitor complex and synthesize the new enzyme. इसके बाद फिर आता है receptor as the drug targets. तो receptors are the proteins that are crucial to the body communication processes. Majority of these are embedded in the cell membrane. Receptors proteins are embedded in the cell membrane in such a way that their small part possessing active sites project out of the surface of the membrane and opens on the outside region of the cell membrane. जैसे यहाँ पर दिया हुआ है कि receptors protein embedded in the cell membrane, the active site of the receptor opens on the outer region of the cell. फिर इधर दिया हुआ है कि a small part of the cell membrane, plasma membrane. फिर इधर receptor protein दिया हुआ है और इधर outer surface of the cell membrane, binding site of the receptor दिया हुआ है, interior of the cell, फिर inner surface of the cell membrane दिया हुआ है. फिर animal cell and the cell membrane दिया हुआ है कि in the body message between two neurons and that between neurons to a muscle is communicated through a certain muscle chemicals. These chemicals known as the chemical messenger are distributed at the binding site of the receptor proteins to accommodate a messenger shape of the receptor site changes. This brings about the transfer of the message into the cell. The chemical messenger gives message to the cell without entering the cell. तो ये दिया हुआ इंटीरियर ऑफ द सेल है, इधर केमिकल मैसेंजर है, बाइंडिंग साइट है और आउटर सरफेस ऑफ द सेल मेम्ब्रेन है. फिर इधर इंड्यूस्ड फीड बाइंडिंग साइट दिया हुआ है. फिर इधर दिया हुआ है रिसेप्टर रिसीविंग द केमिकल मैसेंजर, शेप ऑफ द रिसेप्टर चेंज आफ्टर अटैचमेंट ऑफ द मैसेंजर. फिर रिसेप्टर रीगेन स्ट्रक्चर आफ्टर रिमूवल ऑफ द केमिकल मैसेंजर दिया हुआ है. फिर देयर आर ए लार्ज नंबर ऑफ द डिफरेंट रिसेप्टर्स इन द बॉडी दैट इंटरेक्ट विद द डिफरेंट केमिकल मैसेंजर. दीज रिसेप्टर्स शो selectivity for one chemical messenger over the other because their binding sites have different shape, structure and the amino acid composition. फिर इधर दिया है कि drugs that bind to the receptor site and inhibit its natural function are called the antagonists. These are useful when blocking of the message is required. There are other types of drugs that mimic the natural messenger by switching off on the receptor. These are called the agonists. These are useful when there is a lack of the natural chemical messenger. इसके बाद फिर आता है therapeutic action of the different classes of the drugs. तो in this section we shall discuss the therapeutic action of a few important classes of the drugs. तो पहला है anti-acids. The overproduction of the acids in the stomach cause irritation and pain. In severe cases, ulcers are developed in the stomach. Until 1970, only treatment for the acidity by the administration of the antacid such as the sodium hydrogen carbonate or the mixture of the aluminum and the magnesium hydroxide. However, excessive hydrogen carbonate can make the stomach alkaline and trigger the production of even more acid. Metal hydroxide are better alternatives because of being insoluble. They do not increase the pH above neutrality. These treatments control only symptoms and not the cause. Therefore, with these metal salts, the patient cannot be treated easily. In the advanced stage, ulcers become life-threatening and only treatment is removal of the affected part of the stomach. फिर आता है a major breakthrough A major breakthrough in the treatment of the hyperacidity came through the discovery according to which a chemical histamine stimulates the secretion of the pepsin and the hydrochloric acid in the stomach. The drug cimetidine is tagamate by DNA to prevent the interaction of histamine with receptors present in the stomach wall. This resulted in the release of the lesser amount of the acid. The importance of the drug was so much that it remained in the largest selling drug in the world until the another drug ranitidine Zantac was discovered. तो हिस्टामाइन का स्ट्रक्चर ये दिया हुआ है, फिर उसके बाद दिया हुआ है सिमेटिडाइन का स्ट्रक्चर ये दिया हुआ है, ये सिमेटिडाइन, फिर रैनिटिडाइन का स्ट्रक्चर ये दिया हुआ है। स्ट्रक्चर उतना इंपॉर्टेंट नहीं है, फिर भी देख लेना चाहिए। इसके बाद फिर आता है एंटी हिस्टामिन। तो हिस्टामिन इज ए पोटेंट vasodilator. It has various function. It contracts the smooth muscle in the bronchi and gut and relaxes other muscles such as those in the wall of the fine blood vessels. Histamine is also responsible for the nasal congestion associated with the common cold and the allergic response to the pollen. Synthetic drugs brompheniramine, dimetap and the terfenadine felden are act as antihistamine. They interfere with the natural action of the histamine by competing with the histamine for binding sites of the receptor where histamine exerts its effect. Now the question that arises is, why do the above mentioned antihistamine not affect the secretion of the acid in the stomach? The reason is that the anti-allergic and the anti-acid drugs work on the different receptors. तो ये दिया हुआ है यहाँ पर ब्रोमफेनिरामाइन दिया हुआ है, डाइमेटैप और डाइमेटेन, और ट्रेफेनामाइन दिया हुआ है जिसको हम कहते हैं फेल्डेन। फिर न्यूरोलॉजिकली एक्टिव ड्रग्स जिसको ट्रैंकुलाइजर्स कहते हैं। तो ट्रैंकुलाइजर्स एंड एनाल्जेसिक्स फॉर द न्यूरोलॉजिकली एक्टिव ड्रग्स दीज अफेक्ट द मैसेज ट्रांसफर मैकेनिज्म फ्रॉम द नर्व टू द रिसेप्टर्स. Tranquilizers are a class of the chemical compounds used for the treatment of the stress and the mild or even severe mental disease. These relieve anxiety or stress, irritability of the excitement, or by inducing a sense of the well-being. They form an essential component of the sleeping pills. There are various types of the tranquilizers. They function by the different mechanism. For example, noradrenaline is one of the neurotransmitters that play a role in the mood changes. If the level of the noradrenaline is low or for some reason, then the signal sending activity becomes low and the person suffers from the depression. In such situation, antidepressant drugs are required. These drugs inhibit the enzymes which catalyze the degradation of the noradrenaline. If the enzyme is inhibited, this important neurotransmitter is slowly metabolized and can activate its receptor for the longer period of the time, thus counteracting the effect of the depression. Iproniazid and the phenalgine are the two such drugs. तो यहाँ पर स्ट्रक्चर दिया हुआ है इप्रोनियाजिड का, इधर फिनालजीन का दिया हुआ है जिसको हम नाडेल भी कहते हैं। फिर आता है कि सम ट्रैंकुलाइजर्स नेमली द chlordiazoxide and the meprobamate are relatively mild tranquilizers suitable for relieving the tension. Equanil is used in controlling the depression and the hypertension. तो ये chlordiazoxide दिया हुआ है, ये equanil दिया हुआ है, ये meprobamate का स्ट्रक्चर दिए हुए है। उसके बाद फिर आता है कि derivatives of the barbituric acid, namely the vernol, amytal, nembutal and the luminal and the fecunal. Vernol, amytal, nembutal, luminal and the fecunal constitute an important class of the tranquilizers और ये 2023 में पूछा था। उसके बाद फिर आता है these derivatives are called the barbiturates. Barbiturates are the hypotonic, that means sleep producing agent. Some other substances which are tranquilizers are the Valium and the serotonin. तो उसके बाद फिर आता है वेरोनल का स्ट्रक्चर ये दिया हुआ है जिसके बारे में पूछा था, फिर वैलियम का ये दिया हुआ है और सेरोटोनिन का ये दिया हुआ है। तो ट्रैंकुलाइजर सब है लेकिन बायोटेट्स, वेरोनल, सेकुलर, नेम्ब्यूटल है, ये ट्रैंकुलाइजर्स है। फिर उसके बाद आता है एनाल्जेसिक्स। तो एनाल्जेसिक्स में आता है एनाल्जेसिक्स reduce or abolish pain without causing impairment of the consciousness, mental confusion, incoordination or the paralysis of or some other disturbance in nervous system. These are classified as follow: non-narcotic, non-addictive analgesics and the narcotic analgesics. Non-narcotic and non-addictive analgesics, aspirin and paracetamol, PAF, belong to the class of non-narcotic analgesics. Aspirin is the most familiar example. Aspirin inhibits the synthesis of the chemicals known as the prostaglandins, which stimulates inflammation in the tissue and cause pain. These drugs are effective in relieving of skeletal pain, such as that due to the arthritis. These drugs have many other effects, such as the reducing fever, antipyretic, and preventing platelet coagulation. Because of this anti-blood clotting action, aspirin finds use in the prevention of the heart attacks. फिर आता है narcotic analgesics. तो morphine and many of its homologs, when administered in the medical dosage, relieve pain and produce the sleep. In point of dosage, these produce stupor, coma, convulsion, and ultimately death. Morphine narcotics are sometimes referred to as opiates since they are obtained from the opium poppy. These analgesics are chiefly used for the relief of the post-operative pain, cardiac pain, and the pain of the terminal cancer and in the childbirth. तो ये दिया हुआ है मॉर्फिन का स्ट्रक्चर, ये हीरोइन का स्ट्रक्चर दिया हुआ है, और ये दिया हुआ है इधर कोडिन का स्ट्रक्चर दिया हुआ है। इसके बाद फिर आता है एंटी माइक्रोबियल्स। तो disease in the human beings and the animals may be caused by a variety of the microorganisms such as the bacteria, virus, fungi, and the other pathogens. And antimicrobials tend to destroy, prevent development, or inhibit the pathogenic action of the microbes such as the bacteria, antibacterial drugs, fungi, antifungal drugs, virus, antiviral drugs, or the other parasites, antiparasitic drugs respectively. Antibiotics, antiseptics, and the disinfectants are the antimicrobial agents. So antibiotics are used as drugs to treat infections because of their low toxicity for the human and the animals. Initially, antibiotics were classified as a chemical substance produced by the microorganisms, bacteria, fungi, and the molds that inhibit the growth of or even destroy the microorganisms. The development of the synthetic methods has helped in synthesizing some of the compounds that were originally discovered as a product of the microorganism. Also, some purely synthetic compounds have antibacterial activity, and therefore definition of the antibiotic has been modified, as antibiotic now refers to a substance produced wholly or partially by the chemical synthesis, which in low concentration inhibits the growth or destroy microorganisms by intervening in their metabolic processes. The search for the chemicals that would adversely affect the infecting bacteria but not the host began in the 19th century. Paul Ehrlich, a German bacteriologist, conceived his idea. He investigated arsenic-based structure in order to produce less toxic substances from the treatment of the syphilis. He developed a medicine, arsphenamine, known as the sulfasalfan. Paul Ehrlich got Nobel Prize for the medicine in the 1908 for his discovery. It was the first effective treatment discovered for the syphilis. Although sulfasalfan is toxic to the human beings, its effect on the bacteria Spirochete, which cause syphilis, is much greater than on the human beings. At the same time, Ehrlich was working on the azodise. Also, he noted that there is similarity in the structure of the sulfasalfan and azodise. The AF double bond AF linkage present in the earthphenamine resembles the N double N linkage present in the azodise, in the sense that arsenic atom is present in the place of the nitrogen. He also noted tissue getting colored by the dye selectively. Therefore, the Ehrlich began to search for the compounds which resemble in structure to the azodise and selectively bind to the bacteria. In 1932, he succeeded in preparing the first effective antibacterial agent, protonsil, which resembles in structure to the compound sulfasalfan. Soon it was discovered that in the body protonsil is converted to compound called the sulfanilamide, which is the real active compound. Thus, the sulfur drugs were discovered. A large number of the sulfonamide drug analogue were synthesized. One of the most effective of these, the sulfaparidine. Despite the success of the sulfonamides, the real revolution in the antibacterial therapy began with the discovery of the Alexander Fleming. In 1929, of the antibacterial property of the Penicillium fungus, isolation and the purification of the active drugs to accumulate sufficient material for the clinical trials took 13 years. Antibiotics have either suicidal, painkilling, or the static inhibiting effect on the microbes. A few examples for the two types of antibiotics are shown as below. इधर दिया हुआ H.W. Florey and the Alexander Fleming shared the Nobel Prize for the medicine in 1945 for their independent contribution to the development of the penicillin. फिर इधर दिया हुआ है बैक्टीरिसाइडल और बैक्टीरियोस्टैटिक दिया होता है। बैक्टीरियोसाइडल में पेनिसिलिन, एमिनोग्लिसराइड फॉर ऑफ्लोजैक्सिन आता है। बैक्टीरियोस्टैटिक में एरिथ्रोमाइसिन, टेट्रासाइलिन और कोलमपेनिकॉल आता है। The range of the bacteria or the other microorganisms that are affected by a certain antibiotic is expressed as its spectrum of the action. Antibiotics which kill or inhibit a wide range of the gram-positive and the gram-negative bacteria are said to be broad-spectrum antibiotics. Those effective mainly against the gram-positive or the gram-negative bacteria are the narrow-spectrum antibiotics. If effective against a single organism or disease, they are referred to as the limited-spectrum antibiotics. Penicillin G has a narrow-spectrum. Ampicillin and amoxicillin are the synthetic modification of this penicillin. These have broad-spectrum. It is absolutely essential to test the patient for the sensitivity allergy to the penicillin before it is administered. In India, penicillin is manufactured at the Hindustan Antibiotic at the Pimpri and in the private sector industry. Chloramphenicol, affiliated in 1947, is a broad-spectrum antibiotic. It is rapidly absorbed from the gastrointestinal tract and hence can be given orally in the case of the typhoid, dysentery, acute fever, certain form of the urinary infection, meningitis, and pneumonia. Vancomycin and the ofloxacin are the other important broad-spectrum antibiotics. The antibiotic difradagine is supposed to be toxic towards certain strains of the cancer. ये आ गया जनरल स्ट्रक्चर ऑफ द पेनिसिलिन और ये क्लोराम्फेनिकॉल दिया हुआ है। उसके बाद फिर आता है एंटीसेप्टिक एंड डिसइंफेक्टेंट। तो antiseptics and disinfectants are also the chemicals which either kill or prevent the growth of the microorganism. Antiseptics are applied to the living tissue such as the wounds, cuts, ulcers, and the diseased skin surface. Examples are the furacin, soframycin, etc. These are not ingested like antibiotics. Commonly used antiseptic Dettol is a mixture of the chloroxyphenol and the terpineol. Bithionol, the compound is also called the bithionol, is added to the soaps to impart the antiseptic properties. Iodine is a powerful antiseptic. It's 2 to 3% solution in the alcohol. But a mixture is known as the tincture of the iodine. It is applied on the wounds. Iodoform is also used as an antiseptic for the wounds. Boric acid in the aqueous solution is big antiseptic for the eyes. So disinfectants are applied to the inanimate objects such as the floors, drainage system, instruments, etc. Some substances can act as a antiseptic as well as a disinfectant by varying the concentration. For example, 0.2% solution of the phenol is an antiseptic while its 1% solution is disinfectant. Choline in the concentration of 0 to 0.4 ppm in the aqueous solution and the sulfur dioxide is very low. In the very low concentration are the disinfectants. तो इधर दिया है क्लोरोक्सीजाइनोल दिया हुआ है, टर्पिनियोल दिया हुआ है, इधर बाइथियोनोल का दिया हुआ है. फिर आता है एंटी फर्टिलिटी ड्रग्स. तो एंटीबायोटिक रेवोल्यूशन हैज प्रोवाइडेड लॉन्ग एंड हेल्दी लाइफ टू द पीपल. द expectancy has almost doubled. The increased population has caused many social problems in terms of the food resources, environmental issues, employment, etc. To control this problem, population is required to be controlled. This has led to the concept of the family planning. Anti-fertility drugs are of use in this direction. Birth control pills usually controls a mixture of the synthetic estrogen and the progesterone derivative. Both of these compounds are hormones. It is known that progesterone suppresses ovulation. Synthetic progesterone derivatives are more potent than the progesterone. Norethindrone is an example of the synthetic progesterone derivative most widely used as an anti-fertility drug. The estrogen derivative which is used in the combination with the progesterone derivative is known as the ethyl estradiol, नोवेस्ट्रॉल जिसको कहते हैं. फिर इधर दिया हुआ है नॉर्थेंड्रॉन का स्ट्रक्चर दिया हुआ है और इधर दिया है इथान एस्ट्राडायोल यानी कि नोवेस्ट्रॉल का स्ट्रक्चर दिया हुआ है जो कि ऐसा होता है. इसके बाद फिर आता है इन टेस्ट क्वेश्चन कुछ दिया हुआ है कि sleeping pills are recommended by the doctors to the patient suffering from the sleeplessness but is not advisable to take dosage without consultation with the doctors. भाई फिर दूसरा क्वेश्चन है कि with reference to the which classification है the statement ranitidine is an antacid given below. इसके बाद फिर आता है कि chemicals in the food. तो chemicals are added to the food for their preservation, enhancing their appeal and adding nutritive value in them. Main category of the food additives are as follow. पहला food colors, flavors and the sweeteners, fat emulsifiers and the stabilizing agents, flavor improvers and anti-stalling agents and the bleachers, antioxidants, preservatives, nutritional supplements such as the minerals, vitamins and the amino acids. फिर उसके बाद आता है except for the chemicals of the category 1, none of the above additives have the nutritive value. These are added either to increase the shelf life of the stored food or for the cosmetic purpose. In this section we will discuss the only sweeteners and the food preservatives. फिर आता है artificial sweetening agents. तो natural sweeteners example sucrose add to the calorie intake and therefore many people prefer to use artificial sweeteners. Orthosulfobenzyamide, also called as the saccharin, in the first popular artificial sweetening agent. It has been used as a sweetening agent ever since it was discovered in the 1879. It is about 550 times as sweet as the cane sugar. It is excreted from the body in the urine unchanged. It appears to be entirely inert and harmless when taken. It is of great value to the diabetic person and people who need to control intake of the calories. Some other commonly marketed artificial sweeteners are given in table 15.1. जैसे कि दिया हुआ है अस्पार्टेम दिया हुआ है. तो अस्पार्टेम जो है 100 टाइम्स स्वीट है और इधर अस्पार्टिक एसिड है और फिनाइल मिथाइल एस्टर पार्ट है. सैक्रीन है तो 550 टाइम्स स्वीट है. सुक्रालोज है तो 600 टाइम्स स्वीट है. उसके बाद फिर आता है एलिटेम है तो ये 2000 टाइम्स स्वीट है. उसके बाद फिर आता है अस्पार्टेम. तो अस्पार्टेम जो है अस्पार्टेम इज द मोस्ट सक्सेसफुल एंड वाइडली यूज आर्टिफिशियल स्वीटनर. इट इज रफली 4 times as sweet as the cane sugar. It is methyl ester of the dipeptide formed from the aspartic acid and phenylalanine. Use of the aspartame is limited to the cold foods and the soft drinks because it is unstable at the cooking temperature. Pyrrolithium is a highly potential sweetener, although it is more stable than the aspartame. The control of the sweetness of the food is difficult while using it. Sucralose is a trichloro derivative of the sucrose. Its appearance and the taste are like sugar. It is stable at the cooking temperature. सुक्रा कुकिंग टेम्परेचर पर स्टेबल होता है. सुक्रा स्टेबल है. तो 1/2 कैलोरीज. उसके बाद फिर आता है फूड प्रिजर्वेटिव्स. तो फूड प्रिजर्वेटिव प्रिवेंट spoilage of the food due to the pro, due to the prohibiting microbial growth. The most commonly used preservatives include the table salt, sugar, vegetable oils, and the sodium benzoate. C6H5-COONF. Sodium benzoate is used in a limited quantity and is metabolized in the body. Salts of the formic acid and the propanoic acid are also used as the preservatives. Why do we require artificial sweetening agents? इसके बाद फिर आता है antioxidants in the food. So these are the important and necessary food additives. They help in the food preservation by retarding the actions of the oxygen on the food. They act through the several chemical mechanisms. The two most familiar antioxidants are the BHT and the BHA. The addition of the BHA to the butter increases its shelf life from the month to the year. Sometimes BHT and the BHA along with the citric acid are added to the produce more effect. Sulfur dioxide and the sulfite are useful antioxidants for the wine and the beer, sugar syrups and cut, peeled or dried fruit and the vegetables. इसके बाद फिर आता है क्लीनिंग एजेंट. तो in this section we will learn about the detergents. Two types of detergents are used in the cleaning agent. These are soaps and the synthetic detergents. These improve the cleaning property of the water. These help in the removal of the fats which bind to the other materials to the fabric or the skin. जैसे ग्लिसरॉल इस्टर है और द स्टेरिक एसिड है, सोडियम हाइड्रोक्साइड है और सोडियम स्टीरेट है और इधर ग्लिसरॉल और द ग्लिसरीन बनाए हुए हैं. तो ये सोप्स हो गया. उसके बाद फिर आता है सोप्स. Soaps are the detergents used as a since long soaps used for the cleaning purpose of the sodium or the potassium salts of the long chain fatty acid, example the stearic acid, oleic acid, palmitic acid. Soaps containing the sodium fats are formed by the heating fat, jasmine glycerol ester out of the fatty acid with the aqueous sodium hydroxide solution. This reaction is known as the saponification. In this reaction, esters of the fatty acids are hydrolyzed and the soap obtaining remains in the colloidal form. It is precipitated from the solution by adding sodium hydrochloride. The solution left after removing the soap contains glycerol which can be recovered by the fractional distillation. Only sodium and the potassium soaps are soluble in the water and are used for the cleaning purpose. Generally, potassium soaps are soft to the skin than the sodium soaps. These can be prepared by using the potassium hydroxide solution in the place of the sodium hydroxide. फिर टाइप्स ऑफ द सोप्स देखते हैं. तो बेसिकली ऑल सोप्स आर मेड बाय बॉइलिंग फैट फॉर द ओल्स विद द सुटेबल soluble hydroxide. Variations are made by using different raw materials. Toilet soaps are prepared by using better grades of the fats on the oils and care is taken to remove excess alkali. Color and perfumes are added to make these more attractive. Soaps that float in the water are made by beating teeny air bubbles before their hardening. Transparent soaps are made by dissolving the soaps in the ethanol and then evaporating the excess solvent. In medicated soaps, substance of the medicinal value are added. In the some soaps, deodorants are added. Shaving soaps contain glycerol to prevent rapid drying. A gum called the resin is added while making them. It forms sodium rosinate which lathers well. Laundry soaps contain fillers like the sodium rosinate, sodium silicate, borax and the sodium carbonate. Sodium chips are made by running a thin sheet of the melted soap onto a cool cylinder and scraping off the soap in the small broken pieces. Soap granules are dried. Manufactured soap bubbles, soap powders and the scoring soaps contain foam soap. Scoring agents abrasives such as the powdered pumice or the finely divided sand, and builders take sodium carbonate and trisodium phosphate. Builders make the soaps act more rapidly. The cleaning action of the soap has been discussed in Unit 5. इसके बाद फिर आता है why do soaps not work in the hard water? The hard water contains calcium and the magnesium ions. These ions form insoluble calcium and the magnesium soaps respectively when sodium or the potassium soaps are dissolved in the hard water. तो ये सोप दिया हुआ है, फिर insoluble calcium और the straight soap दिया हुआ है. These insoluble soaps separate as scum in the water and are useless for the cleaning agent. In fact, these are hindrance to the good washing because the precipitate adheres onto the fire of the cloth as gummy mass. Hair bathed with the hard water looks dull because of the sticky precipitate. Dye does not absorb evenly on the cloth bathed with the soap using hard water because of this gummy mass. फिर आता है synthetic detergents. Synthetic detergents are cleaning agents which have all the property of the soaps but which actually do not contain any soap. These can be used both in the soft and the hard water as they give foam even in the hard water. Some of the detergents give foam even in the ice cold water. Synthetic detergents are mainly classified into three categories: anionic detergents, cationic detergents and non-ionic detergents. तो आता है पहला anionic detergents. Anionic detergents are the sodium salts of the sulfonated long chain alcohols of the hydrocarbons. Alkyl hydrogen sulfates formed by the treating long chain alcohol with the concentrated sulfuric acid are neutralized with alkali to form the anionic detergent. Similarly, alkyl benzene sulfonates are obtained by neutralizing alkyl benzene sulfonic acid with the alkali. जैसे कि यहाँ पर दिया हुआ है ये दिया हुआ है लॉरियल अल्कोहल दिया हुआ है, लॉरियल हाइड्रोजन सल्फेट H2SO4 मिलाने पर फिर NaOH मिश्रण पर सोडियम लॉरियल सल्फेट आयोनिक डिटर्जेंट बन जाएगा। डोडेकाइल बेंजीन H2SO4 मिलाएं तो डोडेकाइल बेंजीन सल्फोनिक एसिड बन गया। NaOH मिलाएं तो सोडियम डोडेकाइल बेंजीन सल्फोनेट बन जाता है। इसके बाद फिर आता है कि इन द anionic detergents, the anionic part of the molecule is involved in the cleaning action. Sodium salts of the alkyl benzene sulfonates are an important class of the anionic detergents. They are mostly used for household work. Anionic detergents are also classified in the toothpaste. फिर cationic detergents are quaternary ammonium salts of the amines with acetates, chlorides or the bromides as the anions. Cationic part possesses a long hydrocarbon chain and possesses positive charge on the nitrogen atom. Hence, these are called the cationic detergents. Phenyl trimethyl ammonium bromide is a popular cationic detergent and is used in the hair conditioner. फिर cationic detergents have the germicidal property and are expensive, therefore are of limited use. यहाँ पर दिया हुआ है फिटाइल ट्राइमिथाइल अमोनियम ब्रोमाइड का स्ट्रक्चर दिया हुआ है। फिर नॉन आयोनिक डिटर्जेंट्स Non-ionic detergents do not contain any ion in their constitution. One such detergent is formed when the stearic acid reacts with the polyethylene glycol. जैसे स्टेरिक एसिड ये वाला है, इसमें पॉलीइथेनिल ग्लाइकोल से रिएक्शन किए, H2O मिला और फिर हमारा ये बन गया। उसके बाद फिर आता है कि लिक्विड डिश वॉशिंग डिटर्जेंट्स आर नॉन आयोनिक टाइप. मैकेनिज्म ऑफ द क्लीनिंग एक्शन ऑफ दिस टाइप ऑफ डिटर्जेंट्स इज द सेम एज दैट ऑफ द सोप्स. They also remove grease and the oil by the micelle formation. Main problem that appears in the use of the detergent is that if their hydrocarbon chain is highly branched, then the bacteria cannot degrade them this easily. Slow degradation of the detergents lead to their accumulation. Effluents containing such detergents such as the river, ponds, etc. These persist in the water even after the sewage treatment and cause foaming in the rivers, ponds and the streams, and their waste water gets polluted. These days, the branching of the hydrocarbon chain is controlled and kept to the minimum. Unbranched chains can be biodegraded more easily and hence pollution is prevented. तो इंटेक्स्ट क्वेश्चन दिया हुआ है कि write the chemical equation for preparing sodium soap from the glycerol oleate with the glycerol palmitate. Structural formula of these compounds are given below. ये glycerol palmitate है, ये glycerol oleate है. फिर following type of non-ionic detergents are present in the liquid detergents. Emulsifying agents and wetting agents. Label the hydrophobic and the hydrophilic parts of the molecule. Identify the functional group present in the molecule. इसके बाद इसका summary है कि Chemistry is essentially the study of the materials and the development of the new materials for the betterment of the humanity. A drug is a chemical agent which affects the human metabolism and provides cure from ailment. If taken in doses higher than the recommended, these may be poisonous effect. Use of the chemicals for the therapeutic effect is called the chemotherapy. Drugs usually interact with the biological macromolecules such as the carbohydrates, proteins, lipids, and the nucleic acids. These are called the target molecule. Drugs are designed to interact with the specific target so that these have the least chances for affecting other targets. This minimizes the side effects and localizes the actions of the drugs. Drug chemistry centers around the arresting microbes, destroying microbes, preventing the body from the various infectious diseases, releasing mental stress, etc. Therefore, drugs like the analgesics, antibiotics, antiseptics, disinfectants, anti-acids, and tranquilizers are used for the specific purpose. To check the population explosion, anti-fertility drugs have also become important in our life. Food additives such as the preservatives, sweetening agents, flavors, antioxidants, edible colors, and nutritional supplements are added to the food to make it attractive, palatable, and add nutritive value. Preservatives are added to the food to prevent the spoilage due to the microbial growth. Artificial sweeteners are used by those who need to check the calorie intake or are diabetic and want to avoid the taking sucrose. These days detergents are much in the vogue and get preference over the soap because they work even in the hard water. Synthetic detergents are classified into three main categories, namely the anionic, cationic, and the non-ionic, and each category has its specific use. Detergents with a straight chain of the hydrocarbon are preferred over the branched chain, as the latter are non-biodegradable and consequently cause the environmental pollution.